So you all might be thinking, with all these algorithms, the perfect algorithm is probably what we want to achieve, right? In any sort of case, the perfect algorithm is kind of what we're going for. Never fails, always works. Especially in a medical and clinical sense, we want it to always be, correct. But this is a trick question. The perfect algorithm doesn't work here. Now we're just going to play this video as we talk. So some things we want to kind of think about is that a seizure comes in all shapes and sizes, all forms, looks very different person to person, even seizure to seizure, minute to minute, if not second to second. And a perfect algorithm in this instance or this specific use case is only going to be perfect because it takes the time of the entire seizure length, essentially whenever the seizure happens, to come back and say, oh, yep, that was a seizure. I'm 100% certain that was a seizure. And it's not going to be low latency enough to essentially be able to detect when it is starting, because most of the time it will need to wait the entire time to find the next state of quote unquote normal in order to determine if a seizure actually happened. And obviously that is not going to be very useful for a seizure detection system, because the whole purpose is trying to monitor and be able to intervene or interdict whenever it is happening. As I'm sure if some of you have a more medical background, some of the things that a seizure can do to somebody is essentially create respiratory arrest. It can, they could physically harm themselves, especially if they're doing something that is not just laying in a bed. I'm sure that you might have seen some videos on YouTube where somebody is driving their car, they have epilepsy. All of a sudden they have an epileptic event while they're at a stop sign or something. Their car starts rolling through the intersection. People jump through the window to stop the car. Pretty amazing video. The idea of creating a algorithm or system for detecting a seizure automatically based on computer vision, in this case, is to basically have some sort of response to it almost as like immediately as possible, with making sense. So the statistically perfect approach here is not necessarily so statistical. There have to be some trade-offs in terms of what actually makes sense clinically, which I thought was a very interesting thing to think of. This wasn't really talked about a lot in the paper. They did mention it, but I thought it was a very interesting point they brought up, because it is not the standard kind of thinking whenever we're talking about some sort of clinical device in this case. So as we were talking and as you were looking at that video, you may have noticed, seizures kind of sometimes happen very quickly. Sometimes they can, build up to it. So it's a very interesting problem to solve in terms of what is the threshold that we need to, make the trade-off for in order to, start that response.
I feel like there is a lot of unmet need, and I think when I look at I'm trying to find the FDA, like the formal FDA approval, so I'm having some trouble finding it. I saw that they got like a breakthrough designation, which is really cool because that means like the FDA will review their application a lot faster, but I couldn't find like a formal approval in the database, and maybe it's just me not searching hard enough. But I wanted to talk about this like 10.5% device deficiency. I feel like that's like a huge, as you mentioned, like a huge amount of
Yeah, I thought so as well.
And as someone who's like worked on a lot of device products, like the FDA does recognize pretty closely on like invalids or device malfunctions like this. And I think also true with like regulating this device, it seems like there's a couple of different components, because there is sort of like the algorithm, right, for the device. So that in itself is like one component, and then the hardware is like another component to like regulate. And so like it seems like even like the hardware, there's some issues too with like kind of the more basic hardware. I mean, I'm not, denying that there's going to be a huge market on this, and I do see a lot of merit in computer vision and also VR as well in the medical device industry. So one thing I'm kind of following a little bit more closely is VR as like a way to heal people who have just experienced stroke. So kind of relearning a lot of motor activity. Like I do see like, there being a huge clinical benefit and potential. But to be quite honest, a lot of the devices that are even trying to tackle these problems are just so like infant right now, and I think there just needs to be I think just a better understanding conversation with the FDA on how a lot of these components are regulated, because with every medical device, especially with machine learning algorithms, like there's just so many different parts that require different levels of scrutiny and regulation. And software as a medical device is one field that's really new to FDA regulations, and they just started issuing a lot of guidances in the past years on software as a medical device. So yeah, those are just some of my initial thoughts. It's really like a budding industry, and I agree that there's a huge clinical benefit, but yeah, it seems like all the the products we have on the market right now really don't satisfy this need and demand. And so I can always see, it being uh, uphill from here. Like there's just going to be so much more startups kind of trying to go into this space and more focus on this space.